Hi, welcome back. We are doing Unit 3, or the unit that is the circles unit. And there are two circles unit, and we're doing part 1. So this is the first of 2 units, and this is lesson 1. And we're going over geometry vocabulary and then one of our tangent theorems. So here is our note-taking guide, or the first page. Whoops, I got 2 pages here. The first page of our note-taking guide. And we're going to kind of fill this out and go over some definitions together. Make sure we're all on the same page. So right here we're going to write the definition, then we're going to draw a picture. Okay, everybody knows what a circle is. But what is actually the definition of a circle? The definition of a circle, it is the set of all points equidistant from a point. So the set of all points and I'm going to distant from a point. Okay, so I don't know if you've ever drawn a circle, but you take a tack and you take a piece of string and you circle it around, and you put your pencil on the end of the string and you draw all the way around. Well, that distance is constant as you pull the string around your tack to create your circle. So that's the set of all points equidistant from the same point. So of course we know that we have a circle, but we need to designate what point all the points are equidistant to, and that's the center of the circle. And when we name circles, we always name them by the center. So if this is circle P, then that point in the center is a P. Okay, radius. What is a radius? Radius is the distance in a circle from the center to any point on the circle. Okay, so it's the distance from the center to any point on the circle. So if we are drawing with that string, the string is our radius. When we draw with a tack, we pull the string around. That string is our equidistance. Okay, what is a chord? A chord on a circle is a line segment, first of all. It's a line segment whose endpoints lie on the circle. Lie on the circle. What do we mean by on the circle? That means if you have a circle, those points that are the end points of a line segment lie on the circle. So here is a chord. It's a line segment, and the endpoints have to be on the circle. So you can't draw one where you have one endpoint on the circle and then one point in the circle, or one point on the circle and one point outside. Both endpoints have to be on the circle to constitute a chord. Okay, so what is a diameter? A diameter is a chord. So we're going to say it is a chord whose endpoints lie on the circle, but it has something special on a diameter. It has to go through the center. So a chord that passes through the center of a circle. Okay, so you've got a circle, you've got endpoints, but those endpoints have to pass through that center to create a diameter. And we know that a diameter is 2 radii. So it's a radius from here to here, and then from here to here. Okay, so that's a diameter. Now let's look at secant. Okay, a secant. It is a line or a line segment. Line or line segment that contains 2 points on the circle. Okay, so it's similar to a chord, only it continues. So a secant is a line or a line segment that goes through a circle and it continues. So here's an example of a secant, okay? So it does contain 2 points, but it doesn't stop at those points. It continues. So we'll say it continues outside the circle. Okay, now tangent. Tangent is a very common term that you're going to use, not just here, but later in math too. So what is a tangent? It is a line or line segment. It can even be a ray, okay, that contains only one point on the circle. Okay, now how can we draw a line that only contains 1 point on the circle? So if here's our circle and we have to draw a tangent, it's just going to touch it in one place. So there's a tangent. So it doesn't actually contain any points on the interior of the circle. It only contains a point on the circle. Okay, so that is considered a tangent line. Now let's go down to our picture down here, and we're going to take those terms and try to identify what these are. Let me zoom in just a little bit. Okay, let's start with BH, and notice the symbol on BH is a ray. Okay, so let's look at BH. B starts here and goes on forever. Now B is what we call a point of tangency because it's where the tangent line touches the circle. So BH, being the ray that it is, it's actually considered a tangent. And you could say just tangent, or you could call it a tangent ray. Either one, because it doesn't have, the other arrow on the end of its symbol. Okay, let's look at ED. Okay, ED. It has endpoints on the circle. Well, the segment that has endpoints on the circle is a chord. But notice this chord goes through the center A. So when you have a chord that goes through the center, it is considered a diameter, but it is also a chord, but more specifically a diameter. Okay, how about AD? Okay, A is the center of the circle, and we do call this, circle A. So AD is a radius because it's from the center to the side. CB, C to B. Both of those endpoints are again on the circle. Does it go through the center? Yes, it does. Therefore, it is also a diameter, just like ED was. How about EF? EF. Okay, EF has endpoints on the circle, but notice it does not go through the center, so it is considered just a chord. And then EG. EG has these little arrows on both ends. That means it's continuous. The line continues in both directions. So that gives us a hint. GF goes through the circle, and it contains points on the outside. Therefore, it is a secant. Okay, so those are the terms: radius, chord, diameter, secant, tangent. And then, of course, we call this circle A because A is the center of the circle. So there's our geometry basic vocabulary. I'll scan back over that real quick, and there's all the information on those definitions. Now, we're going to stop for a second and talk about a theorem. Okay, theorem 6.1. I've actually created a little circle here with a tangent on it. Let me zoom back out a little bit for you. Okay, so I printed a circle, and I've got a tangent in the center of the circle, and I'm going to demonstrate for you this concept. Okay, the theorem is on your second page, and it says, in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius of the circle at its endpoint on the circle. Okay, that's a lot of words, so let's just kind of demonstrate. What we're saying is if I draw a radius from the center of the circle to this point up here, point of tangency, and I'll call that T, point T.